We're now in the central local oscillator room of the AOS Technical Building, and I'm joined by Jean-François Cliche, who's going to tell us a little bit about Alma's local oscillator.
Yes, so the function of the local oscillator is to provide a very stable reference signal to all of the antennas of Alma. So Alma is an interferometer, so the way it works is that it measures the time that the light or the radio waves take to get to one antenna relative to another antenna. So since the speed of light is very fast, we must be able to measure this timing with a very, very high accuracy. And so how we do that is that we send a central signal to each of the antenna, a reference signal that is used to synchronize all of the antennas. So the central LO generates these two signals and send them through optical fibers. And one of the problems is that the length of the optical fiber changes with temperature. So essentially what we want to do here is to be able to send a signal with an accuracy of about a few femtoseconds. And
so that's a very short amount of time. I mean, how far does light travel in a few femtoseconds?
Exactly, that's a problem. The light travels a few micrometers, a millionth of a meter, so a thousandth of a millimeter. So the length of the fiber from here to the farthest antenna, up to 15 kilometers away, must not change by more than 1 millionth of a millimeter over 15 kilometers. So that's the other challenge of the central LO. So the other function with the central LO is therefore to stabilize the length of the fiber within that length. And so we have very accurate laser sources that measures the length and then have a stretcher that stretches the fiber here to compensate for any change of the length of the fiber due to temperature changes between day and night or due to antenna movement.
Right. So can we go across and look at some of the hardware?
Yes, yes. These are the central reference oscillator, RF oscillators that generate the RF signals with very high accuracy. These are low frequency signals. Here we take these radio RF signals and then we have these laser sources that generate the light waves that will be sent to the antenna, and eventually we generate these reference signals for...
So these are lasers in the infrared at about 1.5 microns, I think?
Yeah, 1.5 micron. And the one at the bottom is the master laser. This one is a fixed frequency. It's the one also that is used to measure the length of the fiber and do the stabilization. So this one is extremely accurate and stable over time.
So that's a rather special laser.
Yes, that's one that personally I've been working hard over many years.
A significant fraction of your life.
Oh,
think,
yes,
right?
yes. So that's one reason I'm here. And so I want to make sure this works well. And the laser synthesizers are synchronized on the master laser. And we have 3 here because this set of racks is able to support 3 subarrays. Right. So Alma can work with this system so far with as 3 independent radio telescopes.
So that allows us to take 3 different sets of antennas and essentially observe different parts of the sky with separate arrays.
Yes, right. Yes, completely independently. So once we have these 2 signals here, optical signals, they are combined and they are amplified. So here we have the distribution system for up to 16 antennas. So we take these signals and then we amplify them and split them up in 16 ways.
And these orange cables, they're fiber optics carrying light now?
Yes, yes, they are active now. And they bring the light to the next rack, which is the Sudbury Switch. And as the name implies, these selects which subarray, so which group of antenna will be associated to a laser synthesizer. So here we have 8 Sudbury Switch. 8 more are coming to complete the set of 16 antennas for this rack. And once we have selected the right switch, with the right subarray, we send the light to the final rack, which is the line length corrector rack. And as we mentioned earlier, we need to stabilize the length of the fiber for each of the antenna because each are independent. So these modules here contain these stretchers that stretch the length of the fiber to really have a stable signal at the antenna.
So we literally correct for the fiber length changing by getting another piece of fiber and stretching it by an equivalent amount.
Yeah, it's low tech, but it works.
There you go.
So a quick recap. So we had these RF synthesizer. We can see in the front here also a rubidium clock. This is a very stable reference clock. It's an atomic clock that generates the reference RF reference signals, and it is connected also on a GPS receiver in another room, so we can have a very accurate timing that can be that is unambiguous over all the world. So if we want to work with other observatories, well, we can share our data and make sure that everything matches.
And those microwave generators and clocks are commercial items?
Yes. So these are commercial, and the ones at the bottom has been developed in Socorro, I think.
In Socorro?
Socorro by NRAO.
But now the next rack is very special. This is not standard commercial off the shelf.
No,
these are custom things.
Yeah, this is done by a company, Interaction, but it has been developed for the project Alma because it didn't exist. These kind of stabilized lasers, so we see the master laser at the bottom, and this didn't exist as an off-the-shelf product. I mean, you could find it in the lab, and that took a huge optical bench with lots of equipment. And at Interaction, what they did, and I worked part of that team, we took all this hardware and put it in a small box that can work here for 30 years at 5,000 meters of altitude.
I think it's fair to say that 10 years ago this was viewed as one of the single most difficult problems Alma had to solve to make the project a success.
Yes, it's a great responsibility. So we took on that risk, and I mean it took the time it took, but we made it. So it works very well. It's been transported by plane or here and there, and it works. Just plug it in, turn it on, and you have your signal. So that's good. And we have the laser synthesizers also, which has been developed expressly for that project, and that works well. So.
And the proof of the pudding is that we've connected 3 antennas together with the system and got closure phase very recently.
Yes.
So that was the culmination of a huge amount of work by hundreds and hundreds of people, including yourself.
Yeah. Oh yes. It's incredible that it works. Sometimes because you spend so much time worrying about the problems and what can go wrong that you end up being surprised when it works.
Yeah. And it's all in the timing. If those reference signals don't work, then the whole of Alma would not work. It's as simple as that.
Yeah, exactly.